Okay, for today, it's the first day on 10.1. We have 10.1, day 1 and day 2. And what's it about? It's about trig. And the first thing you have to know is that trig involves triangles. And we're going to start with right triangles. Notice the only two triangles on the screen are right triangles, as in they have a what angle in them? A 90 or a right angle. Okay, good. So do you know that if one of your angles is 90, that the other two together have to add up to 90? Does that make sense? Why? Because all the angles add up to 180. Good. All right. So if they're all going to add up to 180, then it makes sense the other two would add up to 90. So if I told you this one's 30, what's the other one got to be? 60. Or if this one was 45, what's the other one got to be? 45. All right, good. So that's how to find the angles in the triangle. And now we just got to figure out how to find the sides. So let's say I said this side was 12, and this angle right here was 32 degrees. What we're going to teach you today is how to find any other angle or any other side in the triangle using trig. So do you remember SOHCAHTOA? If I were you, I'd write that on your paper. SOHCAHTOA. And if you totally know what every letter stands for, then don't write them down. But if you're like, can't really remember what this thing means, it'll really help you to remember this if you write down each part. This is sine, this is cosine, and this is tangent. And what's the O? Opposite. If you want to make abbreviations, that'd be good. And what's the H? Hypotenuse. Here's another and here's a hype. And here's a hype. And that only leaves us with the A's. What are those? Adjacent. I abbreviate that ADJ. And just to remind you of the terminology, if this is my angle I'm focused on, this little angle right there in this three-sided triangle, which they all have three sides if they're a triangle, if that's the one I'm focused on, then what's that one across from it? Opposite. And what's the one next to it? Adjacent. That's really what it boils down to. The hypotenuse is always just the bigger one, or biggest one. All right. So first, would you please write down what goes in all 6 of those spots? You should have it. This is definition now. It's not like for any particular triangle. It's for any triangle. Please write those in. And I'm going to ask you to compare those 6 answers with the kid sitting next to you. I'm going to pair you with rows 1 and 2, etc. right now. Okay, so this one was sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and the last one is tangent is TOA. What's that supposed to stand for, though? Opposite over adjacent. Okay, good. So in this triangle here, what is sine of theta? What is cosine of theta? And what's tangent of theta? For this triangle right here, it's different. You don't say the same things, of course. For this triangle, we know what the opposite is. I'm going to answer those 3, and I'll pause for a second and get attendance done. Here's what I was looking for this time. Should have said sine's opposite over hypotenuse. So opposite from this is A over hypotenuse is C, A over C. Raise your hand if you got that one right. Okay, good. All right, the rest of them then. Cosine is adjacent, B over C. And the last one is tangent, opposite over adjacent, A over B. All right, the main moral of the story for today is we're going to give you triangles, and we're going to give you either one side and one angle, and you can figure out everything else, or we're going to give you 2 of the sides, and you can figure out everything else. So here's the situation. Here's a triangle, and it's going to be your classic 30, 60, 90 triangle. I'm going to give you one side of it. This side over here is 1. Now, this was one that you probably memorized back in geometry. Can anybody remember what the other 2 sides are without having to do any math, just plain memorizing? Anybody got them? Okay, I want to note that nobody is confident enough to raise their hand. And this is the #1 most important triangle that you need for this next 2 months. Memorize it. It's 1, and this one's 2, and this one's square root of 3. Now, does that mean that every triangle in the world has a side that is 1 on it? Of course not. Does that mean every 30, 60, 90 triangle has a side that's 1 on it? No. It could be twice that big. It could be 7 times that big. But the ratios would stay the same. That and that are always a 1 to 2 ratio. Twice as big on that hypotenuse side than the other side. Memorize this one. 1, 2, square root of 3. Got it? Okay, here's another one. It's the other biggie. Instead of 30, 60, 90, what's this one? 90, and what are the other two? 45, 45, 90. Oop, not 44. 45, 45, 90. Okay, and that one, who's got the sides memorized on that one? You remember that one? Nope. That was a classic triangle, but it's not this one. Yes?
1, 1, and then 1.
1, 1, and square root of 2. You are correct, sir. Memorize these 2 triangles. They're huge. Really, really. Like, I refer to them daily during the trig unit. I will be pulling up, making a sketch of one of those triangles every single day as I'm doing keys and as I'm trying to figure out problems for kids. These are huge. So I cannot overstate how important this is. Get them memorized. And you got to be able to, like, if I move them, you got to be able to handle it like, ooh, you drew the triangle different. Now I don't know the numbers anymore. You have to be able to handle making the change. Okay, so let's say this is a 30, 60, 90, or maybe it looks more like a 45, 45. Let's say it's a 45, 45. And let's say this side is 8. Can you tell me what the other 2 sides are? How about at least one of the other sides? Isn't one of the other sides easy? Yeah, one of them's 8. And then what I would do, if I was solving this problem, is I'd make that original one in the same orientation. Notice it's flipped kind of upside down, but I'd label it with 1, 1, square root of 2. And that would remind me how it's supposed to look if it was like the pure simple one. And now, do you get that it's 8 times bigger than the original simple one? And therefore, what's that other side got to be? 8 square roots of 2. It's just as if I multiplied everything by 8. Times 8, times 8, times 8. So this has got to be 8 roots of 2. That make sense? Okay, so memorize those 2 triangles. So I'm going to show you another one in a different orientation. And here's one of the 30, 60, 90s. And if it is 30, 60, 90, can you please label all the sides and all the angles? Draw it the same way I did. Make sure you got a 90 in your triangle. Otherwise it gets really confusing. Okay, what's the small side in this guy? 1. And do you remember that there's a 2 to 1 ratio between that and the big side? What's the biggest side? Gotta be the hypotenuse, right? And in this case, it's what? 2. And then that only leaves one last spot. If you have it memorized, you know it. What is it? Square root of 3. Good. Good. Okay, how about the angles? Think about this logically. What's bigger? 1 or the square root of 3? Think carefully. What's bigger? 1 or the square root of 3? Square root of 3 has got to be bigger than 1, doesn't it? Because if it was 1, 1 times 1 is 1, and we got to get up to 3. So it's got to be 1 point something times 1 point something to get 3. So square root of 3 is bigger than 1. And that makes sense because it's across from the bigger angle. It opened up more here. So that's the 60, and this is the 30. All right. Now, what are these good for? Because, typical scenario, we might say, what's the sine of 30? And you don't have to grab a calculator. You can just sketch out this little triangle quick and go, oh, sine of 30. Okay, sine is opposite of hypotenuse, right? So I want opposite over hypotenuse. I'll write that in red, but that's not actually the answer. In this triangle, what is opposite from the 30? 1 over what is the hypotenuse? 2. Do you get sine of 30 is 1/2? All right, now grab a graphing calculator, and I want you to actually type in sine 30, enter. And if it doesn't come up to 0.5, you're in radians. It's a quick way to test. If yours comes out different, then you got to switch your calculator's mode to degrees. Everybody, if you haven't already, check and see if sine of 30 comes up to a half, and if it doesn't, I want to know how many people had to switch, because a lot of people have to switch. Raise your hand if you had to switch yours. Okay, good. That's more than half the class. Now I want you to understand, what would that do to your ACT test on your 4 problems that are in trig? You know what I'm saying? What if you thought you were getting the right answers, but getting the wrong answer every time because you were doing it in radians by accident? You didn't know. See what I'm saying? So when you take your ACT test, make sure you check it. And if you're a master at this and you're good at radians, which most of you don't even know what they are yet, fine, use radians, but at least know that you're in radians. If you only are good at degrees, and for the vast majority of kids, I'd say this is the safer bet, have your calculator in degree mode. So when you type in sine of 30, you get 0.5. All right, here's another way to check it. It's not quite as snappy, but cosine of 60. What'd you get? Also 0.5. Now why? Because if we write this out, cosine 60 is, it's not opposite or hypotenuse. What's cosine? Adjacent over, and it's totally okay to go so katoa, ka, C-A-H. And the adjacent side from the 60, the adjacent is this one, because it's right next to the 60. Over the hypotenuse is 2. Look at that, it came out a half again. All right. If yours are coming out with a weird decimal again, you haven't switched it properly yet to be in degrees. Any questions on this? How many are feeling like this is easy so far? Good, because it's supposed to be the easy part. All right. So what if I give you just one of the sides? Just one side is not enough to be able to answer a trig question. So if I said this side right here is 11, you can't know what all the other sides are unless I tell you some more info. If I just ask me for one more piece of info, and you'll be able to figure out everything. What else would you need? Yes, sir. One of the angles would be handy. So let's say I said this right here is a 40-degree angle. Now let's use trig to figure out the hypotenuse. What's a good variable for hypotenuse? There's 2 good choices in my mind, since you get to pick whatever variable you want. I don't think A is a good choice. C is a good choice, because hypotenuse, A, B, C, you know, on the Pythagorean theorem, the C is the hypotenuse. C would be a good variable, or what else? H for hypotenuse. Either one's those good. Let's go with C for now. And then if I wanted to make an equation for this, remember, it always starts with sine, cosine, or tangent of an angle equals a ratio, like opposite over hypotenuse for sine, or tangent would be opposite over adjacent. So you can pick anything you want. Do you want to use sine, cosine, or tangent of that 40? Okay. And why would you choose cosine? So tell me what you'd finish with. There's nothing wrong with starting with cosine of 40. What's the next thing? Adjacent over hypotenuse, and the adjacent is 11. Over the hypotenuse is C. Awesome. You wrote me an equation that's got everything in it that I needed. Why would sine of 40 have been a bad choice? Sine of 40. Because what's the next thing you have to write? Yes, sir? Yeah. Sine is opposite over hypotenuse. The first thing we got to do is opposite from here, and we don't know it. So yeah, right away I say, oh, no, not going to use sine. How about tangent? Could tangent have worked? Why can't tangent work? Tangent of 40. Tangent 40 has what in it? Opposite. And we don't have the opposite side. So tangent 40 isn't a good choice either. Still, my point by saying you could pick anything you want is you don't know for sure what you pick, and you keep looking for things until it's like, oh, this one works for me because it has these 2 things in it. All right. So how do I actually solve this then? Well, you'll need a calculator for this next part unless you have cosine of 40 memorized. Okay, so grab your calculator, type in cosine 40, and hit enter. We're going to use 3 decimal places. And don't freak when in your homework it says 3 significant figures. That's not what it should say. This is not sig figs. Obviously, that would add a lot of complication. We're not going to mix that in. It's just when it says 3 significant digits, it means just round to 3 decimal places. So would you type in cosine of 40 if you haven't already? And what did you get?
0.76.
All I did was take out the cosine 40 and put in 0.766. They are the same thing, right? So now it's this equation, and if you can't solve that, we need to move you back because this is honors pre-calc. I'm not saying you know the answer instantly. I'm just saying, could you solve a little equation? I hope so. So how would you start? Yes, sir. I agree. Multiply both sides by c. Clear that denominator. So we times by c here, and we times by c here, and then these c's cancel. And now it's 0.766c equals 11. And now I just set divide by 0.766, and you got your answer. Raise your hand if you have it. Okay, good. So what is 11 divided by 0.766? I can tell you it gets bigger than 11. What's c equal to? 14 point what? 359. And could that be rounded maybe to 360? It probably depends on what you started with. All right. Any questions about this one? That's if they give you a side and an angle. Let me try one just like that for you. Let's say that we make it this way. Could we make that, use that triangle or not? No, because it's not a what triangle? Not a right triangle. Okay, good. How about, could I make the triangle that way? Is that feasible? Yep. So let's say this is going to be 7, and this angle right here is 50 degrees. I want to know how big this one is right there. Let's pause for a second while you give that one a try. Okay, the die of destiny is going to pick somebody who doesn't have to be an expert. Just can tell me something. Row 5, seat 3. Tell me what you think we should start with. Keep going, you're doing good. Okay, so from the 50s perspective, sorry about that. From the 50 perspective, this is opposite and adjacent. I like the way you're thinking. So you knew ahead of time you needed something with opposite and adjacent. Now what? Cosine has opposite and adjacent. Cosine of what? 50 is equal to, this is ca, adjacent over hypotenuse. And the A is the adjacent one, which is question mark over hypotenuse. But wait a minute. Is that the hypotenuse? Oh. Cosine ca, adjacent over, I think cosine would give us adjacent and hypotenuse. We don't really have the adjacent. We have the opposite in the hypotenuse. Which one goes with opposite in the hypotenuse? Tangent goes with opposite and adjacent. Is that the one we want, tangent? Ah, tangent. Okay. So, totally okay. This is going to happen to you all the time. Tangent is TOA, opposite over adjacent. Now let's figure out what the opposite one is. From the 50s perspective, the opposite is 7. Over the adjacent side is, I don't know, so I put a question mark. Now, what would be a good letter for question mark? A. What would be a bad letter for question mark? C, for instance, because that would imply it's the hypotenuse, but it's not. So A would be a good choice. I really can't mark you down for what letter you pick, but I'm just trying to say C would be a bad idea. Okay, so now, if I only do tangent of 50, this would become a super simple little equation. So use your calculator, find tangent of 50. What did you get for that? 1.191 equals 7 over A. And then, first step in solving that, Mr. T. All right. A's cancel. And now, next step in solving that. Divide by 1.191. Whatever 7 divided by 1.191 is your answer. CC, what'd you get for that one? 817?
No, 8, 7.
874. Raise your hand if you had 5.874. Okay, good. All right. Only one more thing to learn. And that's what if we don't give you two sides, or sorry, what if we do give you two sides and no angles? Like let's say this is 8 and this is 12, and I don't want to tell you anything else other than it's a right triangle and there's the right angle. You can figure out everything. You can figure out all the angles. You can figure out that last missing side. You can figure out all of it with trig. Okay, so first step on this is we got to set up some equation, and we got to pick one of these angles to like work on. So I'm going to call this one theta. You don't call it n. You don't call it x. Use theta. That's the standard thing for a variable for a trig equation. Kind of like m is the standard thing for a slope. Then, what do we have? I like when you started that other problem. You said, okay, well, we have the this and the this. What do we have on this one? The opposite hypotenuse, yes. Hypotenuse, longest side in the triangle. And from this guy's perspective, the opposite. So which sign, or which function, dang it, I just said it. Which function should we use? Sine, which is opposite over hypotenuse. So sine of some angle is opposite over hypotenuse. That's great, but what do I do now? All right, now I need to teach you something about solving trig equations. If this had been like 7 times theta equals 21, do you get theta would have to be 3? How would you be solving that, really? What are you doing to both sides? Dividing by 7. Good, because that undoes multiply by 7. Divide by 7 on both sides. How do you undo sine? Does anybody know what undoes sine? Inverse sine. Very good. And it's not cosine. That's the most common wrong answer because they are related. Sine and cosine are related. They're called cofunctions, but don't use cosine. Use inverse sine. It's the little sign with the -1. Now watch. Don't do anything yet. Just watch. If I do inverse sine on the left side, do you get to be fair? Then I have to do it on the right side. So that's what you do. I'm moving this 8/12 over. And I'm going to do inverse sine on this side too. Inverse sine undoes sine. They cancel out. They're gone. So theta is alone, and that's good. The variable's alone. I just got to do this. It's a button on your calculator. It's right above the sine button. You got to hit second to get up there. Inverse sine of 8/12. If I remember right, is this like 14 degrees-ish? 40-some degrees? Ah, a little dyslexia there. Okay, 41 degrees-ish. Specifically, 41 point, remember 3 decimal places. 810? Awesome. There, I figured out my angle. Now, do you get, now that I know that angle, I can figure out the third angle super easy, because this is 41.810, and together these two have to add up to 90. I could just take 90 minus the 41.80, and I know the other side. I know the other angle now. All right. So let's see if you could handle one like this. Let's say we had a triangle, and let's say that this side was 3, and this side was, let me think, 6. I'd like for you to figure out for me, not how long is that side, because you could just use a squared plus b squared equals c squared. And there'd be nothing wrong with that, but I want you to figure out this angle right here. I'll call it theta. Figure out how big theta must be. Remember, go with a trig equation. Yes, sir? Good question. This is supposed to be the right angle. So you start with a trig equation. Like, I'm going to give you a wrong one. Cosine of m is equal to 6 over 3. That's totally wrong, but that kind of thing is what you should write first. When you're done with this one, would you please compare it with the kid sitting across from you? So, did you already, if you haven't already compared, please compare now. See if you get the same answer. I really want you working with that other person. Comfortable with asking them if we get the same thing. All right. You should have said sine of the angle is opposite, which is 3, over hypotenuse, which is 6. And 3/6 is 1/2. And if you're thinking like, oh, I think I recognize this one, that's a good idea. You should think that, oh, I think I know that one. But to be sure, you should probably do inverse sine on both sides. Inverse sine. Inverse sine. And that cancels that. And theta is the inverse sine of 1/2, which comes out to 30. Raise your hand if you had that one right. Okay, good. All right. So, your homework for tonight. I'll show you where it is. It's in, this is our day 2 stuff. There we go. Right there. It's the first thing that says assignment day 1. Okay. Now, it's kind of messy, but on number 1, do you get, they just took a right triangle, which meant it had 90 degrees in it, and they told you one side and one angle. Once they tell you one side and one angle, first thing I would do is have a labeled triangle. So in this case, A is 2.3, so I would scribble this out, put a 2.3 right there. And there's a 30-degree angle at the C, so I'd write in a little 30 right there. And now you've got a labeled triangle, and now from here, it should be just like what we just did in class. Yours is already in there? Oh, it's in number 5. That's weird, because isn't number 5 a separate question?
No, number 1 is a separate question.
Okay, so there's no number 1 really. Okay, I thought that was for number 5. All right, cool. Yay, they already wrote it in for you. Okay, so then let's figure out the third side. Oh, the third angle is so easy. If it's a 30 and a 90, the other one's got to be what? 60. You don't have to make any complicated trig problem for that. All right, but to figure out this side B right here, you're going to want to write a trig function. Would sine of 30 be a good choice? Nope, because sine of 30 would be B over C, and you got 2 variables in it. Not good. How about cosine? I bet it is. Cosine of 30 is, and some kids get confused by this part. I'm just going to write this in as a little helper thing. Cosine is adjacent over hypotenuse, and then I'm going to erase that later. Adjacent for this one is A, which is 2.3, and hypotenuse for this one is unknown. It's a B. And then I erase the A, H, which were just little helper notations in there. And now cosine of 30, if I only knew it, I could look it up on that triangle that you hopefully are going to memorize. Let me show you how quick that is for me. 30, 60, 90, and this is 1, 2, square root of 3. And so if this is the cosine of 30, it's cosine of that, which is adjacent over hypotenuse, which is root 3 over 2. But you're going to want a decimal anyway, so you might as well grab your calculator, and you find cosine of 30 is some decimal. What is it, by the way? What is cosine of 30? It's root 3 over 2, but what is that decimal? 866, thank you. And now I just have to multiply both sides by B and divide both sides by 0.866, and I'll have my final answer. 2.3 divided by 0.866. All right. This is an easy assignment. I looked through it. It's very doable. It's going to take you probably in the neighborhood of 30 minutes. That's our goal, and you should be happy that we're aiming for 30 minutes. I remember teaching in 7th grade for many years, and they encouraged teachers to, well, I should say it this way. A lot of times it was thought like you were not giving enough homework unless you're giving at least 45 minutes of homework. So, but then if you do the math on that and you got 6 classes that all give 45 minutes of homework, it's just obnoxious. So 30 minutes is doable. We're going to aim for 30. Sometimes it'll be 20. Sometimes it'll be 40. But on average, we're hoping for about 30 minutes of homework. So, and today we're started early. You got some time in class to work on it. And it's not always going to be that way. In fact, usually it's not going to be that way because it's complicated stuff and I need to explain it to you and it takes a while. Okay, so there's your homework. And one more thought, since some of you are coming from other classes, I know that some of you never actually graded this homework and put it in the grade book. In my class, we do. We actually take these problems and grade them. And then you're probably thinking to yourself, but aren't the answers posted? Yes. Is it cheating to look at the answers? No. It's totally okay to look at the answers. But you should do it in the right way, meaning you don't look at a problem for 5 seconds and go, I don't know what's going on. I'm going to go look at the answer. That's not the right way. The right way is to struggle with it a little bit, try to figure out what you don't know, see if you can get it to come, because if you can, you work through it on your own, it does help the memory to stick better. But then you should check it. And if you're wrong, don't just copy the answer down, look at the work that's shown and try to learn from that. You really can learn a lot from looking at that. I was trying to learn some calculus last year because I had to take this big math test to become nationally board certified. And it was a hard test. And I had practiced calculus I hadn't seen in so long. And when I didn't have the answers, it was really hard because I didn't know if I was doing it right or not. I could think I was, but until you actually look at the answers, you don't know. So I think if I were you, I would want to look at the answers every night unless the assignment is really easy. If it's like flying through it and easy for you, then sure, you don't need to check it. But if you start getting bad grades, then I would recommend you check it every single night. All right, but when you come tomorrow, if you got the work shown and you got the answers, you're going to be able to get full credit on your first assignment that we grade, and that'll go in the grade book and it'll actually count. It'll help you grade, should help your GPA. If you're a normal human and you make some mistakes and you don't check, that's okay. But if you start getting grades that come out to be D's on your homework, that's not going to help in the long run. Start checking it more. All right, so there's my philosophy on should you do your homework? Absolutely. Everybody always says to do your homework, but I'm actually putting it in your grade, so I would strongly recommend it. All right, that's all I got for you for today.